Okay, we're in lesson 6.2.1 and it should be no big surprise that we're back to the factoring flowchart. So far you've looked at factoring out a greatest common factor. Then in the next lesson we said, well, what do we do if we've got four terms? And the answer was we try grouping. Now we're going down the path for trinomials. In this particular lesson we might or might not have any GCFs, greatest common factors, but we're headed toward this technique called trial and error, which you hopefully can read right there, says reverse of FOIL. So I want to take just a minute and talk to you about FOIL a little bit. So this will be review. What if I ask you to multiply using FOIL, first, outer, inner, last, x plus 2 times x plus 5. All right, the product of the first, x times x, is x squared. The outer product is 5x. The inner product is 2x. They're both positive. They're like terms. I will add them up and they will become positive 7x. The product of the last is positive 2 times positive 5. A positive times a positive is a positive. Okay. What if it had been x minus 2 times x minus 5? I do have a purpose for all these examples that are reviewed. Product of the first is x squared. The outer product is x times negative 5 or negative 5x. The inner product is negative 2x. Now the like terms are both negatives, so I get negative 7x. But negative 2 times negative 5, negative times negative, is still positive. So please notice, let's look at the trinomials. If the last term is a positive, the only way to get a positive 10 is with a plus times a plus or a minus times a minus. How will you know which one it is? Because that's our goal is going to be to factor. The sign here tells you. If this is plus, that means they're both pluses. This is minus, it means those are both minuses. Now we'll talk more and more about these signs, but I have a few more examples. What if I had x plus 2 times x minus 5, where the signs are not the same? The product of the first, x times x, is x squared. The outer product is minus 5x. The inner product is positive 2x. Because one of them's positive and one of them's negative, I actually subtract them and keep the sign of the bigger. So I will subtract for minus 3x. Then the product of the last, plus 2 times minus 5, is minus 10. When I got a negative last term, one of these is plus, one of these is minus, and at least for starting, the larger one carries the sign of the middle term. Okay? Let's look at, well, if I can get to it, one more example. There we go. What if I had x minus 2 times x plus 5? The product of the first is x squared. The outer product is positive 5x. The inner product is negative 2x. They have different signs, so I have to subtract and keep the sign of the big one. This time it's plus 3x. Negative 2 times positive 5 is negative 10. So when you have a plus and a minus, it doesn't matter about the order. You always get a last term that's negative. And this term might be plus or minus depending on what's bigger over here. All right, there is a page that I'd like you to look at. Please don't try to memorize this. Just look at it. This is the model for your trinomial. It might be x squared plus 3x plus 10 or something. It is some trinomial. Anytime this last sign is positive, then the two signs in your factors have to either be plus plus or minus minus, because that's the only way, thinking about FOIL, that's the only way to get a positive last term. Go back. I'm talking about these two. The last term is positive. The two signs in the factors must either be plus plus or minus minus to get that 10. They will be plus plus if the middle term is positive. They will be minus minus if the middle term is negative. Remember, this example or these examples were FOIL, but what we're going to do is this is going to be our problem, and we have to rediscover those factors. If the last sign of your trinomial is negative, then you will always get 1 plus 1 minus, 1 plus 1 minus. Now I'm going to say that sign pattern information almost every time we do a problem that involves a trinomial. So get ready. I'm going to say it a lot. All right. This is 6.2.1, and we're talking about a technique called trial and error. Even though it is not under GCF, I always start a problem by saying, is there a common factor? And the answer to that in this problem is no. So I have x squared plus 14x plus 45. Because there's no common factor, and because it has 3 terms, I immediately write down my 2 sets of parentheses, and I'm going to undo FOIL. I'm going to, and it's called trial and error because as the problems get more challenging, you have to just try some different combinations. Let's take care of the signs because I think that really helps. When the last term sign is positive, I either have to have plus plus or minus minus to get positive 45. Because the middle one is plus, that tells me plus plus. This can be very helpful to you if you remember that. Now, remember, it is the product of the first that gives me x squared. Well, that's pretty easy. It's going to be x times x. It is the product of the last that gives me 45. But there are a lot of different numbers that blank times blank gives me 45. It could be 1 times 45. 2 doesn't go in there, but 3 does. It could be 3 times 15. 4 doesn't go in there, but 5 does. 5 times 9. 6 doesn't go in, 7 doesn't go in, 8 doesn't go in. And when I say 9 and it's already in my list, I know that I've got all the possibilities. Now, which of these is right? Because you put any one of them in here and they will give you 45. But they have to also give you an outer and an inner product that add up to be 14. So I need 2 numbers that multiply together to give me 45 and add up to be 14. It's got to be 5 and 9. I'm just going to put the 5 there and the 9 there. Does it matter where you put them? When both signs are the same, the answer is no. All right, let's check it. Please always check it. FOIL, x times x is x squared. Outer product, 9x. Inner product, 5x. Add them up, 14x. Product of the last, 5 times 9 is 45. So I will enter x plus 5 times x plus 9. And we just did our first factoring of trial and error. The reason that this is written here is that some polynomials are prime, and you're going to begin to encounter that. A polynomial is prime if there is no way to factor it. For instance, the number 13 is a prime because the only way to factor 13 is 1 times 13. The number 14 is not a prime because I can find something other than 1 in itself to factor it. So with polynomials, if the only thing you could do is take out a 1, then it's considered prime. We'll encounter at least one prime. Let's look at number 2. I have x squared minus 10x plus 21. Is there a common factor? I hope you will begin to train yourself that no matter what lesson you're in, what class you're in, that if you need to factor, that you look for GCF first. All right, there's not. It's a trinomial. When it's a trinomial, I'm going to try to reverse my FOIL. Let's do the signs. The last sign is positive. That means either plus plus or minus minus. The middle sign is negative, so it's minus minus. I know that x times x will give me x squared. I need factors of 21. 1 times 21. 2 doesn't go in there. 3 times 7. And that's actually it. Those are all the factors that I could do of 21. Which one's right? The one that gives you an outer and inner that combine to be negative 10x. Well, that means 3 and 7. It does not matter which one you put where as long as the signs are the same. Let's check it. X times x is x squared. Outer product, negative 7x. Inner product, negative 3x. Those combine to be negative 10x. Product of the last, negative 3 times negative 7 is positive 21. These are my factors. It gets a little bit messy, but those are my factors. That's what you will type in. All right. Let's look at number 3. Factor this trinomial completely. I have x squared plus 6x plus 9. GCF? No. 3 terms? I'll try trial and error. The last sign is positive. That means plus plus or minus minus. Middle term tells you which one. It's plus plus. I know I needed x times an x to give me x squared. The factors of 9. Is it 1 times 9 or is it 3 times 3? Well, the outer plus the inner have to add up to be 6. So I hope you can tell that it needs to be 3 and 3. The product of the first, x times x is x squared. Outer product, 3x. Inner product, 3x. Those add up to be 6x. Product of the last, 3 times 3 is 9. Next one, I have x squared minus x minus 72. Is there a common factor? No. Because there are 3 terms, I'll go and try my trial and error. This is the first problem we've had where the last sign is negative. When the last sign is negative, you automatically have 1 plus and 1 minus. It doesn't matter where you put them. You will notice that I will always put the plus first and the minus second. That's just my habit. All right. How do I get x squared? X times x. How do I get 72? Well, there are going to be a lot of combinations. 1 times 72. Now, you may need a calculator to help you with this. Does 2 go in there? Yes, it goes in there 36 times. Does 3 go in there? Yes, it goes in there 24 times. Does 4 go in there? Yes, it goes in there 18 times. Does 5 go in there? No. Does 6? Yes, 6 times 12. Does 7? No. Does 8? Yes, 8 times 9. And since 9 is the next number, I know I'm done, but my goodness, that was a lot of combinations. Many people don't have to write them down, but as a start out, I would say it's not a bad idea. Now, what do I choose? You've got to be careful. Now you've got 1 plus and 1 minus. So when you do your outer and you do your inner, the outer is going to have a negative sign. The inner is going to have a plus sign. You're not going to add them. You're going to subtract them. And you need to get -1. So you're looking for factors. They all multiply together to give you 72. Which pair has a difference of 1? The answer is 8 and 9. Does it matter where you put them? Yes. Not only does the difference need to be 1, the sign needs to be negative. That means the big factor needs to go in the negative slot, 9 and 8. Now, if you put them in the wrong place, hopefully you'll catch it and you'll use your eraser and you'll fix it. X times x is x squared. The outer product is negative 9x. The inner product is positive 8x. Subtract, keeping the sign of the larger. Yes, I indeed get a negative 1. Positive 8 times negative 9 is negative 72. We have the right factors. Next one, I have x squared plus 2x minus 35. Common factor? Nope. Trial and error. The last sign is negative. Hopefully you're beginning to remember these patterns. If the last sign is negative, you always get 1 plus and 1 minus. To get an x squared, we have x times x. Factors of 35. Factors of 35. 1 times 35. 2 doesn't go in there, 3 doesn't go in there, 4 doesn't go in there, 5 times 7. I'm going to be picking the pair of factors that they're not going to add to be 2 because the outer is negative and the inner is positive. They have to have a difference of 2. Yay, it's this group. Does it matter where I put them? Yes. They have to have a difference of 2 and the sign of the big one needs to be plus. So that tells me to put the 7 there and the 5 there. But we want to check it just in case we made a mistake. X times x is x squared. Outer product, negative 5x. Inner product, 7x. Subtract, keep the sign of the big one, that gives you 2x. Positive 7 times negative 5 gives you negative 35. We've got our factors. Let's look at number 6. I have x squared plus 15x plus 29. Common factor? No. Since there are 3 terms, I do trial and error. Remember, if there are 4 terms, you would have gone back to your grouping technique. All right, last sign is positive. That means that it's either plus plus or minus minus. And that tells you it's plus plus. X and x. All right, I need factors of 29. Well, my only choice is 1 times 29. The outer plus the inner, and they're both positive, have to add up to be 15. Do 1 and 29 add up to be 15? No. Do I have any other choices? No. That means that this one is a prime polynomial and cannot be factored. Okay? Let's look at number 7. This is the same strategy as the earlier ones, but there's an extra variable in it, and you just need to see an example. I have a squared minus 6ab plus 8b squared. Common factor? No, there's a lot of similarities, but there's not something in all of them. So since it's a trinomial, I'll do my 2 factors. The last sign is positive. That means it's either plus plus or minus minus. This one says minus minus. To get an a squared, I need a times a. It is not a bad idea to go ahead and notice that you've got a b squared tacked on to the end of it. So go ahead and sneak in your b. When you do the outer product, it will be negative and it will be something ab. And when you do the inner product, it will be negative and it will be some number AB. I know it's BA, but I'm using the commutative property and switching it. So that's where the AB comes from. All right, I need factors of 8. 1 times 8, 2 times 4. Well, which one's it going to be? They have the same sign. They need to add up to be 6. 2 times 4 is 6. 2 plus 4 is 6. So let's try it. A times A is A squared. Outer product is negative 4AB. Inner product is negative 2ab. Those add to be negative 6ab. Remember, when you add like terms, you don't change the exponents. When you multiply, negative 2 times negative 4, that's positive 8. b times b is b squared. So there are my factors. I know it seems like we're doing a lot of examples, but this particular skill needs a little bit of practice, or maybe a lot of practice. All right, x squared minus 3xy minus 4y squared. We've got our x squareds here, or y squareds here. We've got what's called a mixed term in the middle. There's no GCF. I'll go straight to my parentheses. The last sign is negative. Always when the last sign is negative, you get 1 plus and 1 minus. We know x times x gives us x squared. And I know that I'm going to have numbers here, but I'm going to have y's as well. All right, to get a 4, I either need 1 times 4 or 2 times 2. The outer product will be negative something xy. The inner product will be positive something xy. Negative and positive, I'm going to subtract and keep the sign of the big one. Well, since I'm going to subtract, do I want 2 and 2? No, I want 1 and 4. And I'm going to keep the sign of the big one. The sign of the big one has to be negative. It tells me to put the 4 there and the 1 there. Let's check it. X times x is x squared. Outer product, negative 4xy. Inner product, positive 1xy. Positive 1, negative 4, that gives me negative 3xy. I kept the sign of the larger. Then positive 1y times negative 4y gives me negative 4y times y is y squared. Those are my factors. I have 2 more. I have x squared plus 14x plus 33. GCF? Nope. Since there are 3 terms, I go to trial and error. Last sign is positive. What does it tell you? It tells you plus, plus, or minus, minus. That says plus, plus. So I need x and x. Factors of 33. 1 and 33, or 3 and 11. I've been getting these lists pretty quickly. These numbers haven't been bad. Sometimes you have to work on it and use a calculator. All right. I want the outer product plus the inner product, since they'll both be positive, to add up to be 14. Looks like 3 and 11. Doesn't matter where you put them. X times x is x squared. Outer is 11x. Inner is 3x. Those add up to be 14x. 3 times 11 is 33. All right, we have one more. Let's see. X squared minus x minus 20. Is there a GCF? No. I always ask. The last sign is negative. What does that tell you? I hope 1 plus, 1 minus. I know I need x and x. Factors of 20. So it could be 1 and 20, 2 and 10. 3 doesn't go into 20, but 4 does 5 times. The outer product will be negative. The inner product will be positive. So it's going to be a difference of implied 1. So it's got to be 4 and 5. You're going to have to take the difference, subtract, and keep the sign of the larger. The sign of the larger ends up being negative. So that tells me to put the 5 there and the 4 there. If you put them in the wrong place, you will discover it when you check, and then you just erase and move them. The outer product is negative 5x. The inner product is positive 4x. Subtract, keep the sign of the larger, is negative 1x. Positive 4 times negative 5 is negative 20. All right, took us a while to do those 10 examples. Let me just tell you that in our next lesson, we're still going to be doing this trial and error with trinomials. What is going to make it more challenging is that the leading coefficient will not be a 1. And when it's not a 1, then that means it's going to be involved in these two positions. And that means it's going to affect the inners and outers. And I'm going to sometimes make a bad guess, and I will be erasing things. But hopefully that was not the problem in this section, and good luck with your homework.